Network congestion and queuing is a theory which reduces the quality of service that occurs when a network node is carrying more load than it can handle. This video is an example of a normal network wherein the packets arrive at the router and the router passes the packet in, first out basis. But there is a fundamental limit to how many packets a network can handle per second. This limit is known as the line capacity or the bandwidth of a network. And as more and more sources send the packet to the router, then you will run into a problem commonly known as network congestion. The solution to this problem can be active queue management, which is used to control the length of a queue so that it does not run full and create bottleneck in the network. To tackle this problem, many queue management algorithm has been developed, such as random early detection, CODAL, PIE, flow queue CODAL. Amongst these, we have opted to analyze and evaluate the performance of PIE algorithm. As we are working with the throughput and delay parameters in our testbed to evaluate the network performance, PIE is one of the algorithms which handles these both parameters in best way possible. It also improves the stability and does not harm the network when implemented. In this project, we have practically implemented the theory by creating a testbed network consisting of 3 virtual machines, which includes 2 FreeBSD hosts and 1 open source router. To build this testbed, firstly we have used FreeBSD as 2 host machines because it is flexible and can be configured as router, host, or as a server. Secondly, we have configured open source as a router which will route the traffic between the 2 host machines. Along with this, we have used iPuff tool to generate dummy network traffic in our testbed. Here is the demonstration as to how PIE algorithm along with iPuff can be used to manage bottleneck condition in the router. The binary executable file for PIE algorithm has been configured on the open source router for making the decision whether to drop or to forward the packet depending on the queue latency. iPuff tool is installed on both the host machines to generate dummy network traffic for analyzing the network performance. Host A will function as server and host B as a client. For conducting the experiments, we have varied downlink bandwidth along with the delay on the router. We can observe the changes in the network traffic being sent from client to server on the client as well as server's machine. Here we can see a router which has active queue management with PIE algorithm implemented on it. Traffic is coming from various sources on the router. The router checks the queue delay according to the PIE algorithm and takes the decision either to forward the packet or to drop it. In conclusion, we can say that trying to cure traffic congestion by building more links is like trying to cure obesity by loosening your belt. But network traffic can be contained by implementing active queue management on router with suitable algorithms to get desirable results.